Hey there, science fans! Welcome to another exciting episode where we unravel the mysteries of the tech world. Today we're diving into the amazing world of microchips. These tiny components are the unsung heroes of modern technology. You know, those tiny little squares inside your phone, your computer, even your toaster, they're everywhere. They power our daily lives in ways we often take for granted. But have you ever wondered how these miniature marvels are made? It's a fascinating process that combines cutting-edge science with intricate engineering. Get ready for a wild ride because we're about to explore the fascinating journey of microchip manufacturing. From raw materials to the final product, it's a story of innovation and precision. Microchips are like the brains of our electronics. They process information and execute commands, making our devices smart and efficient. They're made of billions, even trillions of tiny transistors. These transistors are the building blocks of microchips, acting as tiny switches that control electrical signals. Think of transistors as microscopic switches that turn on and off, controlling the flow of electricity. This switching action is what allows microchips to perform complex calculations at lightning speed. More transistors mean more power and more features in your devices. This is why newer devices are faster and more capable than ever before. It's mind-blowing how much technology is packed into something so small. These tiny titans are a testament to human ingenuity and the relentless pursuit of progress. But how do we go from a chunk of silicon to a super-powered microchip? The journey is long and complex, involving multiple stages of refinement and assembly. Buckle up because we're about to find out. We'll take you through each step from the initial silicon wafer to the final fully functional microchip. It's a complex process, but don't worry, we'll break it down into bite-sized pieces and use some fun analogies along the way. So stay tuned and let's get started on this incredible journey. Our journey begins with something surprisingly ordinary. Sand! Yes, you heard that right. Microchips are made from silicon, and silicon comes from silica, the main component of sand. It's amazing how something so common can be transformed into something so technologically advanced. The process starts by heating silica at incredibly high temperatures to extract pure silicon. This silicon is then melted and grown into large cylindrical crystals called ingots. Think of them like giant silicon sausages. These ingots are then sliced into thin, round wafers, which will become the foundation of our microchips. These wafers are incredibly thin and fragile, almost like a potato chip, but much more valuable. They're carefully polished to a mirror-like finish, ready for the next stage of the manufacturing process. Get ready to enter the clean room where the real magic happens. Welcome to the clean room. This isn't your average room. It's a place where the future is literally being crafted. It's a highly controlled environment, cleaner than a hospital operating room. Every surface is meticulously maintained to ensure absolute sterility. Even the tiniest speck of dust can ruin a microchip, so workers wear special suits, gloves and masks to prevent contamination. These suits are designed to keep particles from the human body from entering the clean room. Talk about a high-stakes baking environment. Here, precision is key and every step is critical. Inside the clean room, the silicon wafers embark on a long and intricate journey. This journey involves numerous stages, each more complex than the last. They'll go through hundreds of steps, each one carefully orchestrated to create the intricate circuitry of a microchip. These steps include layering, etching, and doping. Imagine building a skyscraper layer by layer, with each layer thinner than a human hair. The precision required is mind-boggling. That's the level of precision we're talking about. Each layer must align perfectly with the previous one. The wafers travel through a series of specialized machines, each performing a specific task. These machines are marvels of modern engineering. It's like an intricate dance, with the wafers moving from one station to another, getting closer and closer to becoming fully functional microchips. Each station adds a new layer of complexity and functionality. One of the most critical steps in microchip manufacturing is photolithography. Think of it like creating a super detailed stencil using light. It's how we print those incredibly small circuits onto the silicon wafers. First, the wafer is coated with a light-sensitive material called photoresist. Then a pattern is projected onto the photoresist using a machine called a stepper. The stepper shines ultraviolet light through a mask, which acts like a stencil, creating the desired pattern on the wafer. The exposed areas of the photoresist harden, while the unexposed areas remain soft. The soft photoresist is then washed away, leaving behind the hardened pattern on the wafer. This process is repeated multiple times, layer by layer, building up the complex circuitry of the microchip. Section 5. Etching and deposition, carving and layering the chip. Once the photolithography process is complete, it's time to sculpt the silicon wafer into its final form. This involves two key processes, etching and deposition. Etching is like using a tiny chisel to carve away unwanted material from the wafer. The wafer is exposed to chemicals or plasma that remove the silicon in the areas not protected by the hardened photoresist. It's like using a cookie cutter to create the desired shape. Deposition, on the other hand, is like adding layers to a cake. It involves depositing thin films of various materials onto the wafer to create the different components of the microchip. These materials might include metals for interconnects, insulators to separate components, or even different types of silicon for specific functions. Section 6. Doping giving silicon superpowers. Silicon by itself is a semiconductor, meaning it can conduct electricity under certain conditions. This unique property makes it an essential material in the world of electronics. But to create the transistors that power our devices, we need to give silicon a little boost. This boost is crucial for the functionality of modern electronics, from smartphones to supercomputers. That's where doping comes in. Doping is a process that transforms silicon into a more versatile and powerful material. Doping is like adding spices to a dish to enhance its flavor. Just as a pinch of salt can make a meal delicious, a small amount of impurities can make silicon incredibly effective. We introduce tiny amounts of impurities into the silicon lattice, changing its electrical properties. These impurities can be elements like phosphorus or boron. By adding different types of impurities, we can create regions of the silicon that are either positively charged or p-type, or negatively charged or n-type. This differentiation is key to the operation of transistors. These p-type and n-type regions form the building blocks of transistors, allowing us to control the flow of electricity with incredible precision. This control is what enables the complex operations of modern electronic devices. It's like creating tiny valves that can turn the current on and off, enabling our devices to perform all sorts of amazing feats. From processing data at lightning speeds to managing power consumption efficiently, doping is at the heart of it all. Section 7. Testing, ensuring quality from chip to chip. After all that intricate fabrication, it's time to make sure our microchips are up to snuff. Remember those billions of transistors? Each one has to work flawlessly for the chip to function properly. That's where testing comes in. Specialized machines probe the chips, sending electrical signals through their circuits and checking for any errors or defects. It's like giving each chip a thorough medical exam to make sure it's in tip-top shape. Chips that fail the test are rejected, while those that pass move on to the final stage of the journey. This rigorous testing process ensures that only the highest quality chips make it into our devices. It's a testament to the incredible precision and care that goes into every step of microchip manufacturing. Section 8. Packaging from wafer to working device. Our microchips have come a long way from those humble grains of sand. They've been sliced, diced, etched, doped and tested. Now it's time to give them a proper home so they can start working their magic in our devices. The wafers are first cut into individual chips, like separating cookies from a freshly baked sheet. Each chip is then flipped over and mounted onto a substrate, typically made of ceramic or plastic. This substrate provides mechanical support and helps dissipate heat generated by the chip. Tiny wires, thinner than a human hair, are used to connect the chip's input and output pads to the substrate's external pins. Finally, the entire package is encapsulated in a protective material, shielding it from moisture, dust, and other environmental hazards. Section 9, the future of small microchips and beyond, and there you have it. From sand to silicon, from wafers to working devices, we've explored the incredible journey of microchip manufacturing. It's a testament to human ingenuity and our relentless pursuit of technological advancement. But the story doesn't end there. As technology continues to evolve at an unprecedented pace, so too does the world of microchips. Researchers and engineers are constantly pushing the boundaries of what's possible, developing new materials, shrinking transistors to the atomic level, and exploring entirely new computing paradigms. The future of technology is inextricably linked to the future of microchips. As we continue to innovate and push the limits of what's possible, one thing is certain. The tiny titans of technology will continue to shape our world in profound and unimaginable ways.